All right. So I guess not too many people are interested in architecting reasoning, but whoever is here to talk about architecting reasoning and learn a little bit more about what reasoning means, welcome. I hope you're doing well. I also hope that you're staying for a little bit longer afterwards because we're running our very own Jeopardy. So everybody who is outside right now, if you're hearing me and can interrupt your conversation, we have a beautiful Jeopardy thing happening right here right in 20 minutes from now. So come and do Jeopardy with us. We will have two great teams face off against each other talking about AI. But for now, let's talk about AI reasoning and how to actually build it, what it means, and where are we right now with AI. This is a kind of a half philosophical, half engineering talk. So I hope you can spare me some time to go through the motions. Um, there's been a big period of time over the past decades where we as humans have done deep research on other intelligent life on this planet, including owls and dolphins and apes and everything else. And by our own manufacturing, we have actually come up with a new creature that we are now competing with, which is the machine, which is AI. And hopefully, one of the things that we will accomplish in the next decade, speaking of how fast AI moves, I would even say maybe in the next 1 year, I hope that we don't find AI as truly competition, but rather as a co-pilot to our lives. And it is important that our co-pilots are reliable. It is important that our co-pilots are enabled by the same tools that we are able to use so that they can help us in our day-to-day lives. So how do we build reliable agents that actually function in the way that we want them to be the co-pilots in our daily lives? So let's start with defining what reasoning actually means, because our co-pilots cannot be dolphins. They should probably reason similar to a human in that capacity. And so one thing that differentiates AI that can reason from anything else, and what differentiates us as humans in our capabilities of intelligence, is the ability to discover things outside of our distribution. And so, reasoning fundamentally, or at least in my opinion, is the ability to learn not by being taught or by memorizing and recall, but simply saying new things by inference. So, if I said, give me a bunch of data that I have never seen before, tell me things that I have never seen said, and I will be able to make some connections, pattern recognition, and infer something about this environment and make a good insight, generate a good prediction. And so we have tried to capture this ability of AI to reason over time, starting from the bottom of this slide, going to the top. At the very beginning, when we were still building these Markov chain based language models, we basically said, we'll just build a statistical model and predict the next words. And to be fair, we haven't really gotten too far from that idea for those who know how large language models work. But the direct Q&A is the very first thing that we were building towards. How do you make a machine answer something? But that was not true reasoning. So then we said, let's try to give the machine knowledge beyond its training data so that it is able to go and model something new that we give it. We go ahead and give it information from web sources. We give it information about some kind of situation we need help with. And then just in context learning came to be. Few shot prompting, if we want the model to behave in a certain manner repeatedly, we give it examples, it followed. So that was all great. Then we realized that just by dumping a lot of tokens into the context window only works to some extent. We said, well, actually, there's more complex missions that the AI needs to do for us. So we need to make sure that it steps through a bunch of small little incremental reasoning steps to come to a solution. And so that's when we started prompting the models with chain of thought, tree of thought, and so on and so forth, and also started training specific reasoning models to include thinking tokens besides just the answer, so that we're able to see how the model goes through the motions of reasoning before it comes up with an insight. And now we are met with machines that are much more fascinating and phenomenal, but yet so much more dangerous than we ever imagined machines could be. These things now own wallets, they have their entire coding execution environments, they can create their own API keys, they can stand up services, and they can interact with you and functionally emulate a human being. And so the question again, how do you build such machines that can reason reliably and safely? And how do you get it across the line to where it actually becomes a reliable co pilot? So let's talk a little bit about the AI engineering lifecycle. So anybody who's a builder in this room, anybody who's a builder watching, you're familiar with this diagram, even if you've never actually seen one drawn before. It is a very simple understanding of you start with scope, you start with your SLAs. That is, you need to figure out what your agent needs to do for you. Does it need to exchange money? Does it need to reason about your healthcare routine or something else? That is always where you start with. Then you go ahead and prototype. You then evaluate, and then based on that evaluation, you need to figure out how well it did, where it could perform better, and then you improve. And then sometimes you start over again. You basically say, maybe the scope is too much, maybe the scope is too little. Let me adjust, reprototype, reprototype, evaluate, improve, and so on and so forth. This is the fundamental engineering lifecycle. And one of the things that we need to understand is that over the past 3 or 4 years, we as humans building AI systems have gotten really, really good at this lifecycle. But yet we still have so much work to do because this life cycle is inherently slow. Every single time we go ahead and set the scope and SLA, we're repeating the same procedure that many of us have done before. You might ask the question, can AI set the scope and the SLAs for my agent? So many people have had many prototypes successful, many less so. Now you might ask, have we learned anything from all of the AI prototypes ever built in the human history, even in the past 3 or 4 years, that we're not able to have AI do that step by itself? And so finally, the question is, how do you automatically evaluate as well and improve AI all without human involvement? And so that is something that I want to press on in this talk, where I say, actually, if we look at the AI engineering lifecycle, can we not only build reliable agent systems, but how can we stand them up completely in an automated way with us just pressing a few buttons? At Sentient, we've done lots of work over the past 2 years. We've been doing research for 2 years. For anybody who in this room who is not familiar yet with Sentient, which you should be, we are an AI research and product lab specialized in AI reasoning. We figure out how to make AI reason better. If that wasn't clear, because this talk is about reasoning. And so over the past 3 years, we've done lots and lots of research. This is just a few highlights. And fundamentally, the research that we've done is centered around three things. It's about architecting things, so reasoning structures like Open Deep Search, using coding for reasoning about search and external tool calling. We've done recursive open meta agent Roma, which has done amazingly well in the research circles. If you want to read the preprint of our academic paper, it's available right now anywhere if you just look it up. And Sarah, which is our exploration on how to properly do tool calling. Do you actually need these complicated reasoning structures, or can you get away with much simpler embedding-based tool calling? So the point of these reasoning structures was to figure out in the AI engineering lifecycle, when you prototype or when you improve, what are the different architectural dimensions and degrees of freedom do you have to play around with, or ideally, which degrees of freedom does your AI system, that is your personal AI engineer, have to tweak with as you improve whatever product that you're building? And so, as you're building these AI systems with AI, you then wonder, well, how do you actually give proper feedback to AI to know what to do? You can't be there as a human in the middle and just prompt the AI to do better and say, change this architecture to that, or reprompt it this way, and so on and so forth. We want to get away with that. And so the second question was to figure out what are the good feedback systems to give to an AI pipeline to conduct these AI agent engineering improvements by itself. And so we've done lots of great work on coding with like CodeBench Pro. We did alignment and security work, and most lately we said lots of these complex agents actually have a huge lack of factuality capabilities. And so we've released Crypto Analyst Bench, which is in some sense specific to crypto, but not so much. You can adapt this benchmark to whatever you want, including medical, financial, and so forth, because the big takeaway here is the valuation pipeline. How are you able to produce good results that you can use as feedback for improvement? And before I continue, just as a moment of silence and recognition, benchmarks of today are very, very bad. And this design of what a good benchmark looks like and how do you build these feedback systems in a reproducible way is actually a giant question. And so if you're familiar with academic conferences around the world, including KDD, they actually have a benchmark track that is now heavily prioritizing papers that are talking all about how do you automatically create benchmarks. So it's not interesting to make benchmarks anymore. It's how do you automatically make benchmarks, but also how do you make sure they're valuable and representative of real workloads that you want AI to become better at. So now that we kind of got that understanding that we're all about reasoning and we're trying to think about how do you actually improve AI, let's think about all of the levers that you as a human have that you also would like AI to have. So at the very basic level, you have a prompt. Many algorithms have come out like JEPA, and if you're following us with our research, we have proposed an algorithm called JEPA Plus concurrently with another research lab, very similar implementations that enable you to automatically improve prompts without your intervention whatsoever. So AI system is built, you go ahead and evaluate it, and you give those traces and results to another AI, and that's the JAPA algorithm. AI by itself will improve the prompt for you, reevaluate, and then suggest further improvements. The second thing you have is tools. And tools have become a very interesting thing lately because the world has moved away from MCP as an abstraction, and the world moved to skills as an abstraction. And skills is a higher level abstraction that basically says, you can combine any prompt or any definition with a bunch of scripts and tools and give it to an AI, and that is what it's now capable of doing. And these skills is what you will see on things like Cloud Code, Open Code, Open Hands, Goose, and other coding agent frameworks. So this is our second degree of freedom. You want to be able to discover tools very easily with your AI to replicate a human engineering process. You want to make sure you can replace tools, optimize them, but also engineer the skills with those tools automatically as well. So not only is it about prompt optimization, but at a more specific layer, you want to make sure that your skills are optimized as well. So now you have 2 degrees of freedom. Third degree of freedom is the scaffold itself, and that is the structure of how your agent is going to reason. If you remember lots of early experimentation in 2024 where people said, let's just give AI a coding environment and set up a simple dynamic planning loop. Many times it will do pretty okay. By the way, this is GPT 4.0 days. So many times you will say the model will do okay, but not that great. And it will never be reliable, and it will never consistently produce the same trace again and again on reruns. So whenever you ask a question, you might expect different answers every single time, just because you don't have very good structure to how it reasons. And so the more freedom you give the model, the more unreliable it becomes. Obviously, new models are much better at this, but as a good scaffold helps the model reason in a much more structured manner. And so in the early days, this was React. Then it was Codact. Then we proposed Roma as a recursive architecting approach, and then finally, the latest installment of the world is going to become an AI slop factory. That's all going to be Cloud Code, Open Code, and all those other guys. So that's the scaffold. And then finally, the fourth degree of freedom is model. And these things might be really tied to each other. Certain models are very good with certain tasks and thus using certain tools, and some other models are better at coding, so they might fit with a coding-based scaffold better. And some other models or different models are simply prompted differently in the most optimal manner. So whenever you as a human are building an AI system, these are your 4 levers. And if you want an automation to do all of these things for you, these are kind of your 4 levers to now teach AI to pull and prod for you. And so this comes back to my previous point, which is as you have these 4 really difficult levers to manipulate, you need to, as a human, understand which one to actually take care of and based on what information. So you presumably have some kind of evaluation that you use as the feedback system. You stare at the traces and you figure out what went wrong, and then you pick which one of the 4 levers to improve. And so, in a very similar manner, if you want to teach AI how to do that automatically, you have to have a pipeline that analyzes the traces, figures out what's wrong, and then the AI will have some guidance on which of the levers to pull. And so, training that from human experience is going to be extremely difficult, but this is going to be the key to creating something that's actually scalable in terms of building agents that are optimized for the tasks that they need to do without any human intervention. And so, as I said, the goal is to trace the reasoning execution of the agent that you're doing, capture that reasoning trace, figure out what went wrong, and then use that as feedback into your system. And this is where the quality of this trace is going to matter a lot. If the quality of this trace is poor, or it's not detailed enough, or your analysis is not detailed enough, you as a human will have to guess as to what to do. And guess what? If you want an AI system to replace you in this AI engineering pipeline, the AI will also guess as well. And so you won't really have a good product. And so at the end of the day, one thing that I want to kind of leave you with is as we're reaching these new levels of um, agents that are extremely intelligent, that have all of these tools available to them, we're reaching a point where it is not enough just for a human to be involved, because these agents need to evolve very, very quickly in order to obey the rules that the creator has set on them. They have to have the tools and the capabilities that the creator wants them to have. And generally, they have to be reliable enough to do so repeatedly and autonomously. And so humans will no longer be enough to get these systems to where they need to be, or at least it will take humans way too long. And so, what my proposal is, that what our interest is right now at Sentient Labs, is how do we take this life cycle of AI engineering, and how can we completely automate it with AI and say, we want to have some kind of evaluation. We want to select what to improve. We want to synthesize different hypotheses, and we want to merge our proposals back into code without human ever touching anything. And so when we automate this upgrade, we will see less human, kind of less human error. We will see the speed at which these systems are brought from nothing to 80% or 85% capability, to speed up from weeks to, let's say, a few hours, just because of how good the AI systems have become at improving themselves. And so this is the self-improvement loop that I hope we're able to achieve. There's a lot of research coming out in the recent few weeks, not months, in the recent few weeks, that has been talking about the self-improvement. Just yesterday, there was a JEPA SWE release that talked about how do you automatically build skills for coding agents just from taking things out of GitHub repositories. So if I give you a GitHub repository of some kind of framework, how do I turn that into a skill that automatically teaches AI how to use it in the most efficient manner possible? And so with their setup, they basically said, well, we were able to go from 50% to 80%. Success rate on the compilation rates, just from training a very, very simple skill, and that's going to be the future of AI engineering. It's going to be AI engineers engineering AI with AI. So what a world do we live in right now? Um, and so, one of the things that is really exciting is, in order for engineering AI with AI to happen, it's really necessary for us to collect as many prototypes and collect as many ideas as possible into a single room about what a good solution looks like. If you told me I would like to build an AI system that is able to make lots of money in crypto, there would be 1,000 degrees of freedom as to how I would design and engineer it. If you told me what is a good financial investment memo, even from person to person, that definition is going to vary. And so many people will make their own definitions and thus their own AI implementations. And so what I will announce today is on February 25th, we're launching a new product called Arena. And Arena is a competition platform where we will bring thousands of AI developers with lots of events in San Francisco to talk about AI reasoning, to build AI, to improve AI, and figure out how do you actually evolve these things automatically? How do we make our lives easier? And how do we achieve the ultimate AI-driven pipeline? So that's all from me on reasoning, and make open source AI win, folks.